to section 18b, which deals with anti-differentiation. So, and this will be pretty straightforward, pretty easy, I think, for you. So if, and notice capital and lowercase here, if capital F prime of x equals lowercase f of x, then we say that capital F of x is an antiderivative of f of x. So we spent several units doing derivatives and finding f, and then you're given f, finding f prime. Now we're kind of going to work backwards. So if I give you a function, I want to find the function whose derivative is equal to that function that I gave you. So for example, we're just going to go through a bunch of examples here, and it'll be a lot clearer after we go through some of these. Find an antiderivative of f of x equals 3x squared. So what that means is I want you to find a function, capital F of x, whose derivative is going to be 3x squared. Now, you know from the power rule that x to the n, when we take the derivative, it's going to be n, I don't need those parentheses, it's going to be n times x, and then we subtract 1 from the exponent. So if we're working backwards, we're going to add 1 to our exponent, and then we're going to have to figure out how to deal with this coefficient that should be in front of x. So, if my derivative becomes an x squared, I know originally it was an x cubed. Now, let's just say it's x cubed. What's the derivative of x cubed? Well, 3x squared. Oh. So, that's exactly what I'm supposed to get when I take the derivative. Now, there's one slight thing we have to remember. X cubed works. How about x cubed plus 1? What's the derivative of that? It's still 3x squared. How about x cubed plus 4? It's still 3x squared. How about x cubed plus 478 and a half? That's still 3x squared. So any constant added onto this is going to give us that same derivative. So what we want to do is include all the possibilities. So we're just going to say plus c, where c stands for a constant. And so that takes care of all the antiderivatives of 3x squared. And if you notice, the graphs of all these answers, all they differ by is a vertical shift. So the shape of the graph is always still going to be the same at any given x value. But just shifting it up or down won't change the slope of the tangent line. You might want to replay that idea again, because that's important. Find an antiderivative of f of x equals x squared. Okay, so we've got f of x. Now, the derivative is an x squared, which means that originally it had to be an x cubed, because I add 1 to the squared. But if I take the derivative of x cubed, I get 3x squared. I don't want 3x squared, I just want 1x squared. So I have to offset that 3 that I would have to multiply when I take the derivative. And so I'm just going to multiply by the reciprocal, which is 1/3. Now if you take the derivative of capital F of x, 3 times 1/3 is 1, and then x to the second power. And then don't forget, plus any constant. Okay, let's try another one. What's the derivative of y equal x? Now notice, this isn't f of x equals, I'm still going to use a capital F. Alright, so this is x to the first power. So before I took the derivative, the exponent should have been 1 more, so it should have been an x squared. Now if I take the derivative of x squared, it becomes 2x. And I didn't have a 2x, I had a 1x. So I need to offset multiplying by that 2, so I'll put a 1/2 in front. Now if you take the derivative of this, 2 times 1/2 cancels, and we get 1x to the first. And don't forget plus c. Okay? Let's get away from the polynomials for a minute. How about y equal e to the x? Well, e to the x is that rare function that it is its own derivative. So we know that my antiderivative is just going to be e to the x, because the derivative of e to the x is e to the x. But also we could add any constant on that as well. and the derivative is still going to be just e to the x. Okay. Ooh, how about cosine x? What function has a derivative equal to cosine? We got that already? That's just sine of x. Double check, derivative of sine is cosine. And then we could also add any constant on there. So, anti-differentiation sometimes bothers students for a while until you realize that it's more of an art form. It's not like taking the derivative where you have rules for everything. It's like, oh, it fits this one, so I use that rule. Antiderivatives is more of an art form, and so you'll see as we get more complicated. These are pretty simple, but as we start to get more complicated, there's not just one certain way to do it. And we'll learn some techniques of how to find these, but they don't always work and they don't apply to every problem. So the easiest thing you can do is write down what you think is the answer, something that's going to get you close. Take the derivative of that answer and see where you're at. And if you need to adjust, make an adjustment. It's almost like a guess and check. Okay, find the antiderivative of f of x equals the square root of x. When you start to get to roots, you want to think of this as fractional exponents. So x to the 1/2. Alright, so how are we going to deal with this? Well, the antiderivative means the exponent is going to be 1 higher. So I know that it's going to be x to 1/2 plus 1. Just like, when it was x squared, our antiderivative was x to the 3rd. We added 1 to the exponent of 2. So we're going to add 1 to the exponent. So it's going to become x to the 3/2. So combine that, and let's write this just as x to the 3/2. Alright, now let's take the derivative of what we have. The derivative of capital F is going to be 3/2 x, and then we subtract 1 from the exponent. 3/2 minus 1 is 1/2. Well, we're close, but this 3/2 shouldn't be there. It's just a 1x to the 1/2. So I need to offset that 3/2 by multiplying my answer times 2/3. Now when I take the derivative of this, it's going to be 3/2 times 2/3, and then x to the 3/2 minus 1. And that's just going to give me x to the 1/2, which is what I need. So there it is. And, hopefully you didn't forget, plus any constant. Alright, let's try one more here. Find an antiderivative of f of x equals 6x squared. Alright, so just focus on the exponent, x to the 2nd. So I know it has to be x to the 3rd. Now, when I take the derivative of x to the 3rd, I get 3x squared. This one is 6x squared. Well, if I have a 2 in front here, now when I take the derivative, it'll be 2 times 3 times x squared, and that gives me 6x squared plus c. Now, if you don't see that too well, here's another suggestion. Take your constant and don't mess with that, just leave it alone. But now for the x squared, we know it's x cubed, and then we have to offset the 3 with a 1/3 like we did earlier, and then when you simplify that, you get 2x cubed. Like I said, for finding antiderivatives, practice makes perfect. What about this one? Last example. Y equals 3. Find an antiderivative. So we're looking for a function whose derivative equals 3. Now, you can think about it a couple ways. Remember, you don't want to fall into that trap of, wait, I have to recognize a certain type of problem and then I do this. You have to think a little higher level here of problem solving. So, when we had linear functions, the derivative is the slope of the tangent line. The tangent line is actually the linear function itself. So the derivative is just the slope. So I need a linear function who has a slope of 3. Well, that would just be 3x plus c. Okay. Another way of thinking about it would be, well, it's kind of like 3x to the 0, so before that it must have been x to the first. And then, well, I need to have a 3 there, so when I take the derivative, it's not just 1, it equals 3. So